least to the series stuff, which we've covered a ton the past couple weeks.
15, it looked like it was.
It was very similar to what we just did on chapter 11 test, so I wasn't overly worried about that. That's why. All right, so if you should have looked at the review test already at some point. Our test is next Tuesday from 5 to 7:30. It will be in this room, so we don't have to go to a different room because some of the classes would get moved. So ours is here, which is great. I should be here 4, so you can get here a little bit earlier. It's 15 questions. Mirrors what I did in the review test. You're allowed 1 sheet of paper, both sides. Has to be handwritten. No photocopying, no pasting, no nothing.
We're talking 8.5 by 11.
8.5 by 11 sheet of paper, yes.
Notebook paper, okay?
Yeah. Yep.
Hear me out. Poster board.
Yeah.
Well, I thought my index cards were pretty fucking large. So I was like,
8.5 by 11 inch.
11 feet.
Yeah, 8.5 by 11. Regular sheet of paper.
Oh my
Those are
god.
5 by 8. Yeah.
These are the largest ones they saw on Amazon.
So
One day when I have
But you know
copious
what?
amounts of money, I'm gonna put
I
8
narrowly
foot back.
missed not taking the final, even though I had this awesome card.
See what I
So-
would do? You should just make your own note cards and put them on Amazon.
Yes, I did.
all right.
10 foot by 5 foot.
So let's look at these. So the first 5 questions of the test are integration problems.
Yes.
Then we have 5 questions that are on volume, arc length, surface area, those cool word type application problems. And then there's 5 series problems that are very similar to the test you just took, which actually for most of you was not a bad test at all. So, all right, so let's look at the integration problems. So the most important part when you're looking at the integration problems is what method do you want to use to solve it? So remember when we were looking at integration, what was the first method? Yeah, the first one method, first of all, just look and see if you can just do it. That's obviously the very first thing you're going to do. But you always want to see if you can look at a use substitution type problem first. And this one, actually, you can do use substitution for it. It's a little trickier than a normal use substitution, but we can. So we're going to set u to 2x plus 1. That means du is 2 dx.
Yes.
Which means 1/2 du is dx. So you can actually do, when you're doing, since this is a definite integral, we can change the actual the interval that we're looking at. So I can do u of 0 is 1 and u of 1 is 3. So I'm changing the 1 and 0 and the 1.
Yes.
Plug it into there.
Sorry, I just.
That's okay. So I have 3x over u to the 3rd and then du over 2. Problem is now I still have an x. So one of the things that typically is not done all the time, but it can happen, is I can take that u and solve for x. So in this case, x equals u minus 1 divided by 2.
Oh, so top.
So now, right. So now I can change this to 3u minus 1 over 2, u to the 3rd, and then du over 2.
Would you want to distribute that out?
Oh yeah, I'm gonna pull out all the numbers, all that stuff in a second. I'm gonna do that right now.
All right.
So I pull out 3/4, and I'm getting u minus 1 over u to the 3rd du.
So will this be? Well, yeah, we'll practice test. So the first problem will be u sub, but will
Not necessarily.
Or there will be a u.
There will be a u substitution problem.
Is that will that u substitution problem look like this one, and
Similar
which
to
you
it.
might have to? Well,
Possibly.
okay.
I'll tell you, like, there's a few problems that are gonna, like, they could vary in different things, and I'll tell you that. So you will have a use substitution problem on it. It could need this, it might not.
Okay.
Like, if I eliminated that X there, you wouldn't need it at all, which is a
Yeah.
possibility. So, like, so don't make the assumption you have to do this. You might have to do this. That's why I chose this problem. So it's the most complicated possible version of a use substitution problem that's there.
Okay.
So, all right. So now we've got this integral. Now I can just literally look at this integral and do it. So now we have to do a little bit of algebra for this one because I want to split this up. So I don't need to have to do necessarily long division and all that other stuff. We can, because op is what has the addition in it. I can split this up like that.
Yeah.
So I have 3/4. Then I have the integral of 1 over u squared minus 1 over u to the third. All right. So what's the integral of 1 over u squared? You did the derivative. You add 1,
Yeah, u to the.
but it's,
3 over
remember,
u.
it's u to the negative second.
Oh, u to the negative.
So it's negative 1 over u. And this is u to the negative third. So it's minus
Minus.
negative 2. Oh, sorry. 1 over 2 u to the third, or 2 squared. Squared.
Yeah, I would just rewrite that.
So 2 negatives make a positive, so I don't have to worry about that part. Now we just plug in the 1 and the 3. If you didn't do change your intervals, you just plug back in the 2x plus 1 there. It's going to give you the same process. So I have negative 1/3 plus 1 over 18 minus negative 1 plus 1/2. So let's see. I change everything to 18s. We've got negative 6 plus 1 plus 18 minus 9. So 9, 3, 4. Which is
Over.
1/6. Multiply.
Yeah.
So it's 12 over 32. Oh, no, sorry. 12 over
Oh.
62.
I said 7 then.
But the 4s will cancel out. The 3, it's like just simplify first.
Oh, yeah.
So
Are you gonna
72.
post this like in the next like day or so?
Yeah.
Otherwise, then you can just fill up like. pictures.
I'm going to post all the notes. Sorry. They'll all be there. I can scroll so you can see it, but if you'd like to take a picture of it, you can.
As I think something and write the.
Yeah, that's fine.
Helps with that.
All right. Questions with that one? All right, because it's a definite interval, we don't need the plus C or anything else like that on there. That's what you're getting with that one. All right, next one.
Integration by parts.
How are you doing integration by parts?
That's up on its own.
Should be.
It's
Was it
the
different
integral
numbers?
of 3x sine.
Oh, it's different numbers. Darn it. That's what happens when I pulled up the other one. Hold on, let me change the bat numbers to the other one.
Is it that?
No, it's just I made it on WebAssign, so it'll change. Actually, the only number that changed was this. It
I'm
was
trying to be sneaky.
a 3 instead of a 7, right?
And actually, it's a-
Yeah. Oh no, I did that one on purpose because I can't stand writing the.
I hate T as a.
I can't write
Variable.
3 T's. So I changed it to T that Texas. But all right, so we'll do the 3. All right, so the 3 I could just pull out, so I don't have to really worry about that part. So how are we going to do integration by parts with this one?
Well, you just change the sin x to like one minus
Actually-
cosine.
That's if it's squared. So as it sits right now, we have 3 pieces.
Yeah, that's why I'm like.
So integration by parts is going to be really messy.
Yeah, that's why I was like.
So
okay.
is there a way? Well, that's integration by parts. Is the
Can
UV, DV, UV, UDU, VDV. You
Can
can
you
do it
use
with
it?
3 things. No, you can't do use of it this way. Because of the extra T. If the T wasn't there, you could.
Okay,
But since that T is there, that kind of eliminates the possibility of doing U substitution.
but we're able to throw it.
So I have, yeah, you can pull out the 3, but that's, so what we really have is we have these 2 things right here. That's really annoying.
Yeah.
So is there a way for me to take that and put it together? So is there a trig identity?
Sine squared plus cosine squared equals 1.
Yes, but they're not squared. Is there a trig identity with sine and cosine?
Probably.
Is it something angle identity or no?
Yeah. It is the double angle identity. Where is the ironic? Hold on. I'm trying to find the actual identity so I can pull it up and put it on screen for you. There it is. All right, so here's the double angle formulas. You don't necessarily have to write down all 3 of these. They're just literally rearrangements of the same thing. So if you write down the first one, you can find the other ones quite easily from that one. I'm giving them all to you because I could use any of those.
The sine of 2 theta.
So sine of 2 theta is 2 sine cosine, right? But I don't have a 2 here. So I can change that sine of t, cosine of t. I can say 2 and 1/2. Would that be the same thing?
Yeah.
Because I'm just multiplying by 2 and dividing by 2. What's 1/2 times 2? 1, right?
Yeah.
So I can change this to sine 2t. So I now have 3 over 2 t sine of 2t.
Couldn't you like technically just do it out? Because never mind.
Okay.
Like you would just skip the step and go straight to the bottom.
Oh, at this?
Yeah.
Yeah, you don't have to write those. Just don't forget the half. Like that's the thing. It's like remembering that half. Like this is not something that most people are going to go, oh yeah, I can just imagine that in the top of my head and I know that piece. Like, so it's sometimes remembering that's important. But you could have gone from here. You could have said, okay, divide by 2 both sides,
Yeah.
and gotten the same concept. All right, now that we only have 2 things, now the integration by parts makes more sense. So I have u du and v dv.
U and
Which one do I want to make the u?
sine of 2t.
Remember the
Oh,
u,
the easier one.
right? So remember it was
We have two.
LAITE, logarithms, algebra, inverse trig, or did I switch these two? I think
Yeah,
I
I think
switched.
it's V8.
Yeah, it's AI. LIA. There we go. Logarithms, inverse trig, algebra, trig, exponentials. So the algebra is first, so t is there. So this is just dt. And this will be sine of 2t. dt. So the integral of sine 2t is what? Sine 2t. What's the integral of sine? Almost.
Negative cosine.
Negative cosine. And there's that 2 in front inside, so that becomes 1/2.
Yeah.
That's that implicit u substitution. All right, so the integral of u v is uv minus the integral of v du.
UDV or UV?
No, it's uv minus the integral of
Okay.
this.
Yeah.
Oh, it's the integral of uv dt because u and v are the pieces.
Yeah.
So I have t 1/2 cosine 2t minus the integral of negative 1/2 cosine 2t dt. So now we only have one thing inside that integral, so that makes life a little bit simpler. But I'm going to clean it up a little bit before I do it, just so you can see it. Pulled out the 1/2, so I don't have to worry about that piece. So it's the integral of cosine of 2t.
So
Yeah,
or 1/2. Sorry.
1/2 sine. So I got negative 1/2 t cosine 2t plus 1/4 sine 2t. Let's see. And since I totally forgot the 3/2 that was in front of this whole thing when I was doing this whole thing,
Where's the other thing?
I have to multiply the whole thing by 3/2. I'm just looking like, wait, that answer seems wrong. All right. So that's the integration by parts. Any questions on this one? Now that Eugene's not here, nobody has questions.
Do you care if I hate using T? 'Cause it's a plus sign?
Why? That's why the test is an X in it, because when I typed it, I put the X's.
Yeah, when I see T, I think a
I
plus
go in
sign.
mine,
on
I
the
did
left.
everything.
Yeah, it's fine. I will tell you right now, there will be no T's on the actual full test. I will make them all X's.
I thought with the integration bar parts, we didn't do anything with the DV.
Yeah, we did.
Or yeah, we did. But
Oh no, you don't use the DV.
that's what it was.
Yeah, you don't use the DV. It's UV minus the integral of V du.
Yeah. I'm trying to like remember.
Yeah. All right, take a couple minutes, try this one. Oh, as I took it off the screen.
Oh.
All right, what method should I use here?
This. The case 3 of the
Yes, partial fractions.
that.
So this is the one where I use partial fractions. So first thing we want to do is split the bottom as much as I possibly can, which in this case, that. So I know this is going to end up being the integral of a over x plus bx plus c over x squared plus 3. So now I have to figure out what a, b, and x is, or a, b, and c is. So we have 2x minus 3 equals a times x squared plus 3. And then we have x times bx plus c. So the only one, remember the trick to making these a little bit easier is to pick numbers that are going to get rid of things. The only one that I can use to get rid of stuff in this case is 0. So if I have x equals 0, I have negative 3 equals 3a. So a is negative 1. So now we got to figure out the b and the c the kind of old-fashioned way. So if I distribute these out, I get ax squared plus 3a plus bx squared plus cx.
And
I go ahead.
we know a is -1.
We do know a is -1, so I'll put that in a minute. I know that a plus b, that's the x squared term, has to equal 0 because there is no x squared term.
Mm.
I know that 2 equals cx, or cx, I should say, because that's the x term. And I know that -3 equals 3a because that's the constant term, which I already knew that was a equals -1/2 or -1. I know c equals 2, and then b would have to equal 1 to make that true.
Yeah.
Well, this one uses, I think it's method 3,
Case 3.
case 3. Any of the 4 cases can be on the test. You will just have one problem with integration or partial fractions. Again, chose a harder one first. All right, so now I have the integral of -1 over x plus 1x plus 2 over x squared plus 3 dx.
Can we separate them and to do differently?
Yeah, I'm going to do that now. Questions on how I got to here? Are we good? So now let's split this up into some integrals that I can work with. So -1 over x plus the integral of x over x squared plus 3. Plus the integral of 2 over x squared plus 3. All right, so this one is just negative ln of x. This one we have to do what?
So,
Yeah, we have to do substitution on this one. So if u is x squared plus 3, du is 2x. So I have the integral of, so 1/2 1 over u. So it's 1/2 ln of u. So this is 1/2 ln of x squared plus 3. This one right here, you have to use that tangent rule. So it's a over, so yeah. Yeah. So we have 2 over the square root of 3, arctangent x over the square root of 3. Plus c. So I'd make sure I have that arctangent rule written down somewhere if you don't have it memorized, which I highly doubt. That one does come up quite often. All right. Any questions on partial fractions? Remember, the only difference in the cases is the linear terms always just have one letter over them. So that's in essence what you do in case 1. Any quadratic terms have a linear factor over them. That's why we did bx plus c. If there is multiples, so if it was, for example, x squared, that would have been 1 over x and 1 over, or sorry, not 1 over x. It'd have been a over x and then b over x squared. So when you have a raised to a power, you have multiple of those terms, you split them up that way. You have to write every factor up. So if it was x to the third, I'd have a c over x to the third. And the same thing is true when you have multiple factors. So like if it was x plus 3 to the third, it would be ax plus b over x plus 2 to the third, cx plus d over x squared plus 3 to the second, and then so on and so forth. You are not going to have one that long. Don't worry. It will be no more than 4 letters.
Thank you.
So, okay. All right. I think your test had what? 3?
From 0 to 4.
No, it's still pi over 4.
I was like,
I was saying it was still pi over 4. Yeah, it was just 3 instead of. All right, so you've got tangent 3 theta and then secant squared theta. D theta. So what am I doing with this one?
Trig identities.
breaking down that.
Yeah.
So okay, if I break down the tan, what do I do? What am I breaking down the tan as?
You're taking out one tangent, so you have tangent times
And
tangent
apart.
squared.
Because something about that has something to do with the
Yeah, there's a tangent rule that allows you to put
And
them
secant.
together. Yeah, you get more secants, or you do it the other way around. You get more tangent. It's like one way.
Okay.
Here, let me find it.
Why?
Oh,
Why?
oh,
You're right.
yeah.
What's the integral of tangent? Or what's the derivative of tangent?
Secant squared.
Secant squared.
Yeah.
So this is literally just a u
I was right
substitution.
now. I was like,
So tangent of theta is u. So du is secant squared theta d theta.
and then now.
So
we
this
have
is so let's do the 0 and the pi over 4 so we don't have to worry about that piece.
tangent of 0 is
So u of 0 is 0. U of pi over 4 is 1. So I have u to the third du.
Wouldn't it be? Oh, never mind.
What's up, Aiden? Hold on. I can't
Sorry,
hear.
I had to turn my mic on. You
Oh.
you already put it down. It's 1.
Yeah, okay. All right. So u to the third is the integral of that is u to the 4th over 4. And we're evaluating from 0 to 1. So the answer is 1/4.
Oh, why did I put it back in the?
That was it.
That was it.
I would have been doing that for like an hour and a half and it's still probably.
I'm just having my brain went to the right place of like, hey, those two are related.
Well, that's the key. It's like look for things that are related.
Yeah, because I knew they were related.
So, like sometimes the really complicated problems don't turn out to be that complicated.
But this is a trig rule.
And so, yes.
What?
Not in any way like it works.
All right. This one. I think yours was 4 and 49. Yeah, I know. I just put the dx out as y. I just wrote it that way. You can write the dx on top too.
And we can't just. Yeah. Yeah, we can.
What?
The square root has to stay. Because there's.
So this one you need to use one of these. This one other little rule that I know we did it. I showed you at one point, but this is the rule we need for this one.
I don't remember seeing that rule.
Well, now you've seen it. It was when we did a whole bunch of like the ones with the square roots and the x's and the squares and the. I do believe I put this one up there when we did the partial fractions one because it was one of those ones that can happen, but if you do it out with partial fractions, it becomes really messy. So this one just works out nice this way.
And so what about the X that we have there?
All right. So the problem is this is not in that form.
Yeah.
So we have to do some algebra work or possibly some other things to get it into that format.
So did you pull the 1 over x out to make that?
No. So, because so the way this works, I need it to be an x squared minus an a squared on the bottom, which I don't currently have.
You can't just do the square root of the stuff.
No. Correct. So that does not equal 2x plus 7. All right, so we've got to do some work here to make this something usable with this rule. So it's not as simple as, oh, yep, there's my answer, I'm done. All right, so what's the annoying piece of this problem?
That square root.
That square root, right? Okay, so let's say if we make u 4x plus 9 or 4x plus 49, then du is 4 dx.
Yeah.
So I know dx is 1/4 du. But I also have, again, that little x right there, right?
Yeah.
So let's take this and solve this. So I have u minus 49 over 4 equals x.
And the 4 would go back on top. Right?
Probably. We're going to do some algebra in a second. It's not a definite integral, so I can't find the endpoints or anything of this one. So we're going to have to go back at the end. All right. So I've got 1 over u minus 49 over 4 times the square root of u. So u to the 1/2. And then I have 1/4 du.
So 1/4 outside.
Yeah, this is a separate piece. It doesn't really.
My algebra brain kind of tells me to bring that. Like, but the 1/4 and the 4 underneath the u minus 49 kind of cancel. I don't know if that's wrong, but like that's what I'm bringing it to.
What?
That the 1/4 and then the divided by 4 under the u minus 49.
So we have it. Oh yeah, because that's going to flip up top. So
Yeah,
yeah,
that's
those
what's-
will cancel out.
Okay.
Yeah. So I am having 1 over u to the 1/2 times u minus 49 du. All right. Not like how the book did this one. I don't think it U squared minus 49 there. Okay. I'm trying to decipher their work.
Did they distribute?
Sometimes that one works out as hard. I don't know where they went.
Did
I
they
know.
distribute the u to the 1/2 into that?
Oh, they made, okay. They actually, all right. They made you the whole square root piece.
Oh.
So that's
Is
what
there
they did.
a perk to doing that? Like, could we continue how we went now? Or would we have to go back and make our u that square root?
Where'd that X? Where'd the X go on this problem? Oh, that's a U. Okay. All right. Actually, we're going to do it that way. We're going to do it their way. I'll explain it their way. Because it actually does make life a little bit easier. We're going to have to do another substitution here, which I think is going to confuse you more than just redoing this part here.
All right, so
Aiden, you can just talk.
All right.
When I
Wouldn't we be able to multiply the u to the 1/2 and distribute it, and then just take the square root and square each of the sides?
You can't square the two sides, though.
Oh
That's
yeah, but you can cancel them out. So if you take this, so if you multiply it out, you'll get u to the 3/2, and then that can turn into u to the 3/4 squared. And then that's
Oh,
nine.
yeah. That's going to be messy. I got what you're saying.
Yeah.
We're going to go I think the other way actually is cleaner.
All right.
I got what you're saying. Yeah, that we could do that, but I think this is going to be cleaner. All right, so this is u squared equals 4x plus 49.
Oh, they just
should bust out the big eraser.
ruining my paper. Oh, and that way you can just cancel out stuff.
So this is 2u du equals 4 dx.
Which is 1/2 du equals dx.
Yes, 1/2 u du equals dx.
So the u's on top in that case.
Yeah. All right. And then we can solve this for x. And we get u squared minus 49 over 4 equals x.
Oh. Yeah.
All right. So we now have 1 over u squared minus 49 over 4 times u times 1/2 u du.
Which becomes a 2 on top, right?
So this ends up being 2 over u squared minus 49 du.
And now we have that form.
So because the u's will cancel out, so that u and that u cancels out. And I ended up having 4 over 2, which is that 2. And now we have it in that format.
And our A is 7.
So in this case, A is 7 from that. So we have 2, because the 2's out in front. 1 over 14. ln of u minus 7 over u plus 7. And remember, u was the square root of 4x plus 9, 4x plus 49.
Now we plug that
So
back
1/7 ln square root of 4x plus 49 minus 7 over the square root of 4x plus 49 plus 7 plus c.
This problem kind of sucked.
Yeah.
Like if you hadn't told us that we need to put the square root with the 4x, what's for I
So if you did it the other way, you'd have ended up getting, what was it, 3/2, right? Yeah.
yeah.
It was 3/2, which you then would change to u to the 3/4 squared. You'd have ended up doing something with that to get the actual 2 pieces. It would have been messier.
So like, is there a sign I should look for to know to just put that square root in with the u?
Yeah, you tried it and realized it came out to be messy, and you try something else.
Yeah.
And sometimes that's actually what you end up doing. Like it's just, that's why I did. I'm like, okay, I did this. Like you knew where you had to get to. It's like,
Yeah.
because it was something along those lines. Like, okay, I don't have. It's not a simple rule that we had, because if you remember the trig identity one or the trig substitution ones were the square root of x squared plus something, or like it wasn't the square root of it. It was just the x squared plus things like that. This is a square root in it, so it's something different. So we have to use that rule. So
What is that rule called? Or like what's the name of the rule?
it's an integral rule. Like there's no real specific name for it. There's like 190 of them at the end of your book.
I just want to know like what to write down on my paper to
That.
no, I have that. Right.
So it's when you see something with the x squared minus, like when you see something with 2 squares on the bottom, you need to use this.
So if I see like a
Like this problem right
9,
here.
9 and 81, I would be like,
Yeah, if it was like x squared minus 81, it's like, oh, okay, then that's the answer. I'm done. Like I have that there.
Okay.
Like this one is one of those problems where you look at it, it's like, okay, I don't know where to go. So let's try to do something with it to see where I can get to.
Okay.
And then you try. And that's unfortunately sometimes where we're looking at the series problems is the same concept, is that you're going to run into problems that isn't always a straightforward method here to do it. Like you have to play around sometimes with them. So not every problem will be simple. Pretty much. All right. Volume.
This is
So how do you determine if it was disk or
shells when they all match up.
the
Like it's
shell?
X equals an X equal. And disk is if do I have it backwards?
Oh, and this problem is the X is 6.
This would be
Is
Disk,
this,
though,
this one?
right?
Is that what you're trying to tell?
Yeah.
Okay, everything else is the same except it's X equals 6. Got it.
I was just. Another factor in sense.
I was trying to figure out what you're talking about. I'm like, huh?
Like, how did she get that?
I'm like, that's 6?
but this would be disk though, right?
Yeah, why?
Because you have Y equals about the X axis.
Yeah. So, right. It was the opposites. So if it's all the same, you use the cylinder method. So like, I'm sorry, what's wrong screen? There. So if it was X equals around the X axis, we use cylinder. If it was Y equals around the Y axis, we use cylinder. Since it's Y around the X axis, we use disk. If it was X along the Y axis, we use disk. So this is disk. You do.
The recital. That
So,
was amazing.
what I typically would do in past times, and I didn't tell you guys, I don't know why, you could technically just bring your 3 index cards if you want.
So I feel like that would be.
I don't even know if I have the 3 index.
So, because that's actually where the sheet of paper came from, because we used to have 4 tests, 4 index cards. It was about the size of a piece of paper.
Yeah.
So I would
I
let
was
you just
pretty
bring
sure
them.
my index card.
Yeah. So you could just bring your 3 index cards.
But then where am I gonna fit all this?
Right. So then bring your paper. All right. So what's the formula for the disk method?
Hold on.
That's a great question. That's a wonderful question, Mr. Baker. Let's see if I can find it. Pi r squared.
Why is it pi r squared?
Because that's the disk method.
So the disk method
And
actually
our
it's,
R is outer minus
So-
inner.
so it's just the area. The area of your disk is pi r squared.
Yes. Or
So
R is
in
out-
this case, a of x is pi r squared. Question is, what is r?
it's our outer function minus our inner function.
Right. So in this case, I only have one function.
Thank God.
So it's just going to be
X minus 1.
pi square root of x minus 1 squared, which is pi times x minus 1. So your formula is your area. That's the area of a disk, pi r squared. And if you remember looking at, so actually I'll pull up the graph so you can see this one.
And I would just do the integral of X minus 1
So
from 0 to 6.
this was the graph. So we're looking at it
From
from
1 to
this is my radius because we're rotating around.
yeah.
So that's my radius. So that's where that came from. Now I need to figure out my A and my B. So this is y equals 0 and x equals 6. So where does y equal 0 for this problem? Because we need the terms of
Oh, at
x's.
1.
So for y equals 0, so 0 equals the square root of x minus 1. That's x equals 1. So my integral is going to go from 1 to 6, and it's pi x minus 1 dx. So we can pull the pi out. The integral of x is x squared over 2. The integral of x of 1 is x. And we're evaluating it from 1 to 6. So 18 minus 6 minus 1/2 minus 1. So 12 plus 1/2. So 25 pi over 2.
Oh. Yep. Okay.
Twelve is 24 over 2 plus 1/2.
Don't worry,
Times the
I
pi.
did the same thing for a second.
So
Stop, I feel like you're giving everybody. My dog has pizza. And we gave it to the other one. I feel like
I think I tried once and it was like,
I'm having like psychosomatic.
all right. Questions with the disk method? Next one is shell method. It's 9. Okay.
oh, because we have y equals and it's about the y axis.
Right. So this one's around the y-axis, and we have y equals. So this will be the disk or the shell method. So your formula for the shell method, it's 2 pi x times the height. 2 pi. So the formula is AB 2 pi x times the height dx. So it's circumference times height. Since we're going around the y-axis, it's x, so that's y-axis. If it was the x-axis, it would be that way. So the height is my equation.
Yeah.
So, and since we're going around the y-axis, we have, so it's 2 pi times the x times 9 e to the negative x squared dx. So the question is how do we find my limits? Since this is in terms of x, I would use the x's, so 0 to 1. Ooh.
No, no.
All right. If this looks familiar, we just did one recently with that. And if you remember right, we can't do it.
I mean, I remember you saying it every time, but I don't remember.
We did it with actually with the Taylor series. We actually did or the McLaren series later on. We did it with series, but you couldn't find that integral because you need something to do your substitution with. In this case, I have that, so I can do this. So I just don't want you to look at it and go, wait, I remember seeing something we can do that problem. You can because we had the X there.
We
Well,
can't
I
do
didn't get
the
there.
we can't do the integral of x tangent x though.
All right, so my U is going to be that. So du is negative 2x dx. U0 is 0, and U1 is negative 1. So we have 0 to negative 1. We have the 2 and the x here.
Yeah.
So I just have that negative sign,
Oh, I
which I can pull out front with the pi.
don't we have 2 pi out front? Oh, we got rid.
I'm
I
using-
see.
And we have a 9 that's coming out front too, so I can pull that 9 out. So it's e to the u.
Oh, well, this became a lot easier. Wait.
What?
Yes.
What's the integral of e to the u?
E to the u. I hope.
So e to the u, and we're doing it from 0 to negative 1. So I have negative 9 pi e to the negative first power minus e to the 0 power is 1.
Do we just leave it like that?
I'm going to get rid of my negative sign because technically areas can't be negative. And this one actually isn't negative, but it kind of looks like it's negative. So we just switch all the signs.
Yeah.
But technically what I have on top isn't wrong. Like this isn't wrong.
Okay, so I can just leave it like
This
that.
is just rewritten in a nicer way. So you will have a problem that does disk method and one that says shell method. They will not tell you which method you need to use. It just says find the volume of the solid.
Rotate it about.
So you'll need to determine which one to use. All right. The next one is from, which ones do I have it from? 16 to 25. All right. So this one, I need to know the formula for arc length.
It's the integral of that.
Kind of. That's the one for X. It just switches for Y. So there's the arc length formula. So I need to take the derivative of what I've got there, square it, add 1, take the square root of it. So if you remember right when we were doing these, we did everything underneath the square root first, and then we kind of worked our way outwards from that, doing the algebra steps. So step 1, find the derivative. So this one, it doesn't make much difference how you do it, but I'm going to actually, I think distributing this one's going to be a little easier than dealing with it elsewise. So I can pull out the 1/3. Actually, let me rewrite this first before I. Don't worry, I'm going to rewrite that in a minute. So I have y to the 3/2 minus 3y to the 1/2. So my dx dy is 1/3 3/2 y to the 1/2 minus 3/2 y to the negative 1/2. So we've got 1/2 y to the 1/2 minus 1 over y to the 1/2. Oh, actually, you know what? I'm going to leave that as a negative exponent, just so I don't have to deal with all the fractions. All right, so that's the derivative piece. Now what do I got to do to it?
Square.
I have to square it. So I got 1/4. You've got y. Minus or plus 2. Minus 2. Do you know where I got the minus 2 from?
I would have done algebra for like 10 minutes to get there.
Okay. Do you know where I got it from, though, right?
Can you
Okay.
tell me where you got it from?
The middle terms. Y to the 1/2 times y to the negative 1/2 is 1.
Yeah.
And you have 2 of them. Because you have to do the opposite direction, too. And then plus y to the negative 1.
Okay, I was like,
So that's the squared.
yeah.
But now I have to add 1 to it.
Yeah.
So let's distribute this through. Huh? No, I said no fluorescent ink when you're doing your test.
I am simply highlighting the stuff I want to put on a note card.
No,
on a piece of
he was
paper.
talking because I was using highlighter to, because
Oh,
it's faster for me to hit the highlighter than change colors.
maybe I'll do my entire final in hot pink pen.
There you go. It makes it really easy for me to grade.
Oh yeah.
1/2, -1/2 plus 1.
Hmm.
So remember, this was one of those ones that kind of goes back on itself. Where it looks like it's really complicated. But remember, I have to be able to get rid of that square root, otherwise I can't do this problem. So you're going to have something that's going to get rid of the square root. So somehow I've got to factor this to get it to be squared.
How
Okay.
did you factor it?
You're looking for two numbers that multiply to 1/4 y, and which is going to obviously be 1/2 y to the 1/2, and 1/2. Two things are going to multiply this, and since it has to be a perfect square,
Yeah, one has to be positive.
they have to be right. So,
Yeah.
All right. So now, when we take the square root of that, we have our integral of 1/2 y to the 1/2 plus 1/2 y to the -1/2 dy. And we were looking at this one from 16 to 25. So we have, I'm just going to pull out the 1/2, so I don't have to worry about it. 2/3 y to the 3/2 plus 1/2. Oh. 2 y to the 1. Yeah. And we're doing that from 16 to 25. So 2/3 times 125 plus 10 minus 2/3 times 64 plus 4.
How do I do that? Now?
You have access to calculators. Comes out to be 70/3. Got it. Okay. How do I find surface area?
It's kind of like arc length, right?
It has arc length in it.
Yeah.
So your surface area formulas were
How is that for A to B, 2 pi y?
Yeah.
Or-
so there's a variety of them, but in essence, it's a matter of where you're rotating and what you have.
And sometimes that y is an equation, right?
Right. In this case, it's going to be an equation. Sometimes it's just y.
Yeah.
It really depends on what this is in here. Since this is solved for y, it's y equals, we're going to replace that y with cosine 1/6x. If it was x equals and I'm solving for y, I would leave that y there. All right. So what do we got? So y is that. So I still have to find my dy dx. I have to find my derivative of this.
Which would be once
What's the derivative of cosine?
negative sine.
Negative sine. And it's going to be 6.
Yeah, that's yeah.
Remember, it's always the opposite of whatever is inside.
Whatever you say, whatever.
Yeah, whatever you think.
Also equal.
We gotta square that.
And we have to square that. Oh, I'm stupid.
Okay.
Because I literally made the same mistake that I guarantee everyone here would make. We found the derivative. We're not doing U substitution. We're doing chain rule. So it's not the flipped. It is just 1/6.
Okay, so I was like,
It's the chain rule, not U substitution. This is what happens when you like literally going back and forth between them. It's really easy to screw up those little things.
okay, because I was like, what's it?
Okay. So now we've got to square this. So now we square it. So we get -1, or actually not negative. 1/36 sine squared 1/6x. Don't square the inside of the 1/6.
Otherwise, you're wrong. Then +1, right?
And now I have to add 1 to that. So I'm going to end up getting 36 plus sine squared of 1/6x over 36.
Okay. Why is it 36 plus?
Well, it would have been that plus 36 or 36 plus, doesn't make a difference. No, it doesn't make a difference because it's addition. In addition, I can swipe. And now I got to do my square root of that.
That's
So we end up with, so the surface area is the integral from, which one was I doing this from? 0 to 3 pi? Of 2 pi cosine of 1/6 x. And then we have the square root of 36 plus sine squared 1/6 x over 6,
Why is it over?
square root of 36.
Wouldn't the top off?
Nope.
No.
So I can pull out pi over 3. I have cosine of 1/6 x.
Then you sub.
Yep.
Right. Derivative of sine is cosine, right?
Yeah.
We're supposed to do that.
No.
Like I'm looking
I
back,
have
like,
been doing
half the
that.
people are writing in our corner.
All right. What's your substitution?
36 plus sine squared 1/6 x.
So I can take so I'm using what for my u?
36
Oh,
plus
using
sine
all-
squared 1/6.
Okay.
That's right, and it's working out kind of nice. So
So du is what?
1/6 cosine 1/6 x.
That would be incorrect.
Or is it? Oh, it's 6, isn't it?
Nope.
No. Well, it was working out real nice this way.
So let's just look at sine squared x. Let's just make this simple.
Oh,
That is, in essence, a chain rule.
yeah.
Well, no, I made it. You can't do this the way he was doing it. So, but that would be the first thing that everybody would try to do is just make that whole thing a u. So if you did this, actually your du comes out to be cosine, or actually it's 2 cosine x sine x,
Yeah, that's.
which I don't have that over here to do with.
See, but if
So-
you just do it wrong, it all works out nicely.
Well, yeah. All right. But if I make u just sine of 1/6 x, then my
There you are, morning.
du is just that.
DUs. Okay, I was.
So what I get,
The square root of 36 plus u squared.
so actually let's change my things. So u of 0 is 0 and u of 3 pi is Sine of 1/2 pi
One.
is 1.
Okay.
Okay, and we can pull out the 1/6. So I've got pi over 18, 0 to 1, 36 plus u squared. du.
Illustrator.
So I now have to figure out that piece.
Another you said?
I can't do this
Oh yeah,
substitution.
you're right. Because
I have to do trig substitution.
So are you gonna make the exam like flex length?
That's a great question. I know it's the final.
Or just exactly this?
Yeah, use Desmos.
Just use Desmos.
So every time you say, I don't know if like the Desmos app on my phone is wrong, but I can never type anything into Desmos, have it actually do it.
So, okay, so when you're,
Obviously operator error. but-
so when you're doing
Isn't that
this,
one problem we have, where we're just like, oh, you're just putting Desmos.
All right,
right
you first of all, you have to use the graphing calculator app for this one, not the scientific app.
You want to have yeah.
You have to use this one for it.
I think it's slash calculator.
100%, but
Okay, so now click on where it says functions and scroll down, and you'll find your integral symbol.
It is infinitely easier on a computer.
Oh yeah, so you could just type in integral.
well, that's where I usually use it, and I'm like, I can't.
Yeah,
I
did you
tried
find the
to
integral?
find out, Yes.
So now we're gonna do 0
So, I'm sorry.
to 1. Hit the square root. 36 plus,
You got a one and put it next to the one. No problem. 36.
you can use X, it doesn't matter. Well, now you have to use the keyboard to get the U. The X is right there.
The ABC book.
Huh?
The ABC.
Yeah, it'll give you the keyboard
Another keyboard. Yeah.
Gives you another key.
on your keyboard. Yeah.
Because graphing.
No,
Oh.
it gives you the number right next to it.
I was trying to look at a graph.
Uh-uh.
Okay.
Yeah, you're not looking for.
Again, I don't know why that would have been helpful.
Don't we have to
but
type
I
in what
felt
our
like
U
I could
equals,
use
though?
it.
No, we found you. We
Oh, yeah,
found the
because we
integral
have
in
the
terms of
new-
U. Right.
Yeah.
So this one is 6.03.
Did you multiply it by
And
pi
that's
over
what
18?
Oh, I didn't multiply by pi over 18. You're right.
God.
There you go.
Oh,
So 1.05.
oh my,
Pi.
hold on.
Or do we need the pi?
That number implies.
Oh yeah, it's implying pi.
Yeah.
Yeah.
Pi is a number.
Pi is just 3.
All right.
It is just 2.
It's very possible. The one that you're going to have in the test will not need trig substitution.
Thank goodness. So,
All right. We're going to get through exactly where I thought I was going to get through. Question 10. Actually, I think I changed slightly, so I'll use the.
So if we were to have left it at pi over 18. interval
I wouldn't have marked. I would have. Seriously. Oh,
minus
For those that
30.
maybe can't use this. Not
Minus
calling
30
anyone out,
points.
but
instantly fail the final.
All right. So here we go. There we go.
Oh,
Your mosquito problem, the simplest problem to do on the thing. It's just
take
the integral of this. Between the weeks they gave you. So 5 to 9.
Easy peasy. Lemon squeezy.
So 1500 T plus 10 over 0.9, which is 90.
Yes.
No.
No.
Oh, it doesn't actually work out nice.
What is the 0.9 increase on the X code?
It's not a power. It's an E.
Oh,
And the only reason it's going down there is because of U substitution.
oh yeah, because you have to use the
Yeah.
0.9, yeah. And that gives me some value.
Yes. So 1500 times 9 plus 10 over 0.9 e to the 0.81 minus 1500. 0.9 times 9.
Isn't
Oh,
it 0.9D times 0.9D?
That's right, 0.81. 0.1.
Okay.
I was off by decimal. E to the 4.5. Which again, you're going to type in the calculator to get the answer.
Oh, next time I'll still be right outside in classes, not to be. Yeah, like an April 1.
9 times 0.9.
Whoa.
Or 0.9
I'll
times
have to sleep the
0.9.
whole time and then have questions.
Yeah.
Yeah, he was awake for this one, so I'll give him that one.
I came back to class and I was like, yeah, this is. So I locked in right away.
This was the user.
Yeah, unironically, yeah.
I don't want to, I spoil it.
Yeah. Not to be that guy, but this problem's probably the least of your problems.
Oh, that's why.
Did anybody drop the class?
So 41,605.
And we use Desmos for that?
Yeah.
or-
Yeah, I just put the decimals.
Not the graphing part.
Yeah, you're gonna type that in sentence. You can type it either way, but
So, does the app like switch between, or do you have to like also download this thing?
there's two calculators. Yeah.
One is in
That
the
explains
link.
a lot,
So-
too.
Okay. So I will tell you that everything you can do in the actual calculator app, you can do in the graphic calculator. So you could type that problem right in as is into that box in your graphic calculator. It will give you the answer. You do not have to switch over to the other
Like
calculator to
right
get the
when we
answer.
started this class, I was like, oh, let me go get my graphing calculator. I spent $1 million on when I was younger. Open it up and the batteries exploded in it and I couldn't clean it. And I was like, I'm not spending $120.
You want to know what you should have used? Isopropyl
Not
alcohol.
leave the- not-
Well, no,
practice
isopropyl
in it.
alcohol will actually clean it out. Isopropyl alcohol.
I don't know why that did.
Yeah,
We're
that-
talking 70% or 91. I
You wanna-
haven't thrown it out yet.
As crazy as 91.
I'm like, I can't.
The only
throw it out.
okay, the only difference. So the only difference between them is how much water content's in it. So electronics, less water.
Yeah.
That makes sense. Yeah. So the 91.
Don't want to
Yeah.
ruin it.
All right. Do I need to put up the video for this series, or
If
Can I
you think
just-
any are particularly weird,
can I just put up the answers?
So
Let's
there
start
was
with
like one of
answers.
them.
yeah, we'll start with answers, and if we have an issue, we'll let you know.
Because no, honestly, they're basically very similar to the test you just took.